A good morning. Welcome back to the channel and welcome to day 4 of learning Kubernetes. This is a happy morning on my end. I don't know where you're watching from, but I hope it's either a bright afternoon, a bright evening, or morning for you. So let's learn the Kubernetes API. So yeah, I want to focus on this right now. So you may know or not, I run 2 streams every day. One in the morning when I learn something like Kubernetes, in the evening where I build the project. And of course, later when I need to, I'll have to apply Kubernetes to that project. All right. So let me start the Kubernetes API. So here they say the Kubernetes API lets you query and manipulate the state of objects in Kubernetes. Remember, the Kubernetes API server is one of the components of the control plane. If I take you just back uh, behind, I think a few days ago, we looked at the components of the Kubernetes cluster, okay? We see that is a control plane. And you see, one of the components of the control plane is the Kube API server, which is responsible for exposing an HTTP API, okay? So it's what now we are focusing on, okay? So where is that? I think, yeah, this is it. So let's go ahead and learn this together, all right? So they're saying the core of Kubernetes control plane is the API server and the HTTP API it exposes, okay? So this is the core. That's why if you look at the thumbnail, I say the heart of Kubernetes, okay? Because the API server is the core, the real core, like the central point of the control plane, okay? Which is the API server, which helps everything else communicate, okay? So let us read this again. They're saying the core of Kubernetes control plane is the API server and the HTTP API that exposes it. The users, the different parts of your cluster, and the external components all communicate with one another through the API server. Okay, so the components, for example, like the kube control manager. Okay, if we need access to the etcd, which is the storage, if we need use of the components, maybe interaction with the cloud control manager with cloud providers. Okay, all that we are being told is possible using the API server. Okay, even us as a user, if we want to communicate with the Kubernetes cluster, okay, in different parts of the cluster want to communicate, they all use their communication goes through the API. Okay, so let's continue. They're saying the core of Kubernetes control plane is the API server. Okay, this is of course a repetition. And if you hover over here, they will simply tell you what we have learned in the past 3 days. And they're saying the container orchestration layer that exposes the API and interfaces to define, deploy, and manage the lifecycle of containers. In simple terms, giving us an interface to help us define a container, okay? Maybe start a container, stop it, and stuff like that, okay? And then API server, which you already know, okay? It's the component in the control plane which serves the API, which gives us the API. So they're saying this API server exposes an HTTP. The API server exposes an HTTP API that lets end users, different parts of your cluster, and external components communicate with one another. Okay, they're just actually repeating what they said up here. So I'll go to the next paragraph. They're saying the Kubernetes API lets you query and manipulate the state of API objects in Kubernetes, for example, pods, namespaces, config maps, and events. Okay, so what I understand from this statement is that a pod, okay, a pod is an object, is an API object. Namespaces are API objects. Config maps are objects, okay, and events, okay. So using the API, I can query. So to query is to request for something, to do something, okay, perform a request. Okay, I can perform a request on the pod, okay, or maybe on the namespaces, config maps, or events. Okay, I can manipulate namespaces. Okay, I can manipulate a pod. Okay, I can maybe check the state of an event. All this happens using the API server. Okay, let me now go ahead to read the next statement. So here the next statement, it says most operations can be performed through the kubectl command line interface or other command line tools, such as kubeadm, okay, which in turn use the API. So I don't know how this is pronounced. Please correct me if I'm wrong. And also kubectl, okay. So yeah, I think ahead we shall look at what kubectl and these are, okay, when we start now doing stuff. Now they're saying, however, you can also access the API directly using REST calls. So there are two ways you can perform operations: using REST API calls or using command line interfaces, okay, through things like kubectl or kubeadm, okay. So they're saying Kubernetes provides a set of client libraries for those looking to write applications using the Kubernetes API. So 3 ways, okay? Command line, REST calls, or client libraries, okay? I will now move on to the next. They're saying each Kubernetes cluster publishes the specification of the APIs that the cluster serves. There are 2 mechanisms that Kubernetes uses to publish these API specifications. Both are useful to enable automatic interoperability. Okay, so let's see the 2 mechanisms. They're saying, for example, the kubectl tool fetches and caches the API specification for enabling command line completion and other features. They're saying the 2 supported mechanisms are as follows. Okay, so they mentioned the first one. First one is called the Discovery API, okay, which provides information about the Kubernetes APIs, okay. And they're saying this includes the API names, the resources, the versions, and supported operations, okay. So the Discovery API simply gives us the names, okay, of the APIs, the resources that are tied to these APIs, the versions of the APIs, and the operations that we can do using the APIs. And I think if you've done any development before, you know that if you're going to use an API, okay, you must know the names of the API, first of all, okay? You must know the resources attached to this API, because an API it gives you access to a resource, okay? So this should make sense, okay? First of all, you need to know the API name, okay? When you know the API name, secondly, you need to know what resource is attached to this API, okay? After that, what versions am I dealing with, okay? Because one version could have something you want, another version could have something you do not want, okay? And then an API should have supported operations on the resources. Yeah, this is how I understand it. Then they're saying this is a Kubernetes specific term. This is a Kubernetes specific term, as it is a separate API from the Kubernetes OpenAPI. They're saying it is intended to be a brief summary of the available resources, and it does not detail specific schema for the resources. Okay, it's a brief summary of the available resources, and it does not detail specific schema for the resources. And now they're saying, for reference about resource schemas, please refer to the Open API document. Okay, I'll leave that for now. So we're now looking at the next mechanism. Remember, they have told us about 2 mechanisms. Okay, 2 mechanisms that Kubernetes uses to publish API specifications. The first mechanism is the Discovery API. Remember, For you to be able to use an API, you need to know the API specification, okay? And the Discovery API, like we have seen, helps us to know the API names, the resources, okay, that these API names are going to help us to access the supported operations. For example, an API could help you to only have one operation. That operation could be maybe making maybe a get, okay? But you cannot maybe modify anything. You can only fetch information. You cannot modify. Then the next one here says the Kubernetes API document provides full open API version 2 and 3.0 schemas for all the Kubernetes API endpoints. They're saying the open API version 3 is the preferred method for accessing open API as it provides a more comprehensive and accurate view of the API. They go ahead to say it includes, let me highlight this and then read it. They say it includes all the available API path as well as all resources consumed and produced for every operations on every endpoints. Okay, it includes all the available API path as well as all resources consumed and produced for every operations on every endpoints. They're saying it also includes any extensibility components that a cluster supports. Okay, and the data is a complete specification and is significantly larger than that from the Discovery API. So what I get from this is that the Discovery API simply gives us the API names, the resources, the versions, and supported versions. Okay, but it's not enough. Okay, the Kubernetes Open API documentation has everything. Okay, it's the full thing. Okay, and it gives us way more than Discovery API. That's what I perceive from this. If you've understood it differently, do not hesitate to let me know in the chat. Okay. So now, if I guess they're now trying to talk about each of them a little bit in detail. Okay. So what are we going into? Ways of finding out of interacting. Okay, the API specification. So we have seen the Discover API and the full documentation. Okay, so let's talk about here. I think now they're talking about the Discover API in detail. So the Discover API, let's go on. They say Kubernetes publishes a list of all group versions and resources supported via the Discovery API. This includes the following for each resource. So what is published? Group versions and resources. That's the key takeaway. Okay. So this includes, number one, we find out the name. Okay. We find out the cluster or namespace scope, the endpoint URL and supported verbs, alternative names, the group, version, and kind. This is similar to like to REST. Okay. For those of you who are backend developers, you should find this kind of like familiar. Okay. This should not be new to you. Okay, because even like in REST, if for you, even if you're not a backend developer, you maybe a front-end developer. If you're a front-end developer and you've worked in the industry, I'm sure at least you've interacted with at least one API. Okay, you'll need the resource name. Okay, you'll need the endpoint. Okay, and supported verbs. Like in general REST, we have things like get, put, patch, options. Okay, post. Okay, and then versions, okay, stuff like that. So it's very similar, okay, and this makes sense. Why for each resource, okay, we need the name, a cluster, an endpoint URL, and the supported verbs, alternative names, groups, versions, and kinds. Makes perfect sense to me. I don't know what you guys say, okay. And again, I am not like a guru here, okay, or some wise guy. I'm just learning. Okay. So in case we're learning together, okay, you find out that what I'm saying is not true, okay, and it's not clear, and you can help me understand it better. Do not hesitate to mention it. Let me actually look at the chat just to make sure I don't miss out on any wisdom you may share with me. I would really appreciate. Okay. Don't just watch me fail and you keep quiet. Don't hesitate to let me know. Okay. whether it's tough. Okay, I'll accept tough criticism from you. So let's go on. So they're saying the API, okay? They're saying the API is available in both aggregated and aggregated form. Okay. I hope they explain what this is. I don't understand what they mean by aggregated and unaggregated. But let's read on. They're saying the aggregated discovery serves two endpoints, while the unaggregated discovery serves a separate endpoint for each group version. Okay. So just to back up again to read here, they're saying the Discovery API publishes a list of all group versions and resources. Okay. Group versions and resources. These are the two things I'm understanding from here. And every group version, each resource includes the following. Okay. Then they're saying this Discovery API is available in both aggregated and unaggregated. Okay. The aggregated, okay, the aggregated discovery serves two endpoints, while the one which is unaggregated serves a separate endpoint for each group version. Okay. So aggregated two endpoints, unaggregated separate endpoint for each version. Okay. Let's go on and see what they say. So next up is aggregated discovery. Feature state. Kubernetes version 1.3 stable and enabled by default true. I don't know what this means, but I guess we shall understand it as we read. They're saying Kubernetes offers stable support for aggregated discovery, publishing all resources supported by a cluster through two endpoints. Finally, like I told you, it is similar to REST, okay? To REST or the usual web development, okay? So you see the two endpoints. The first endpoint is this one here, /API, and the other endpoint is /APIs, okay? So all resources are supported by a cluster through two endpoints. We have /API and /APIs. So you're saying requesting this endpoint drastically reduces the number of requests sent to fetch the discovery data from the cluster. How does this reduce the number of requests to fetch? I hope they explain this. Let me read on. So they're saying you can access the data. You can access the data by requesting the respective endpoints with an accept header indicating the aggregated discovery resource. I want to read this again. You can, let me move this up so that you can see it clearly. I keep forgetting sometimes to do that. So they're saying you can access the data or the data by requesting the respective endpoints with an accept header indicating the aggregated discovery resource. So this is how the you can this is how the structure of the header will look like. Okay, like of course, like in web development, we know if you know this. Okay, you say accept, you mention the header name, then to put the value of the header, you put this full colon. Okay, then we are seeing here that it's accepting application JSON. It's the data format. Okay, then we have a key called v. Okay, equals to v2. Okay, this is the first pair. Okay, and each of them are separated by these semicolons. Okay, this is what I see, and I'm just how I'm interpreting this is from my knowledge from the general web development. Then you have G being equals to, I think this is the group. They're saying API discovery .k8.io. Okay, then the semicolon again marks the end. They're saying as equals to API group discovery list. Okay, so the whole goal of this is to indicate that the accept header, the goal is this, okay? Requesting, we want to access data by requesting the respective endpoints, okay? So the accept header helps us the goal is just to access data, okay? In simple terms, to summarize it. Now they're saying without indicating the resource type, using the accept header, the default response for the API and API's endpoint is an aggregated discovery document. Okay, so this is aggregated if we don't indicate the resource type using the accept header, okay, they are saying it will be unaggregated. All right, let me go on. So they're saying the discovery document for the built-in resources can be found in the Kubernetes GitHub repository. Okay. They're saying this GitHub document can be used as a reference of the best set of the available resources if a Kubernetes cluster is not available to query. Okay. So if you're learning with us and learning with me, please, I suggest that you you don't miss any, okay? Because learning needs consistency. There was day one, okay, of me learning this, but today is day 4, okay? And in this documentation, you'll discover that so many concepts are going to be repeated again and again to reinforce our understanding. So if you do this every day, trust me, by the time we make a month of studying Kubernetes, our knowledge will be way far, very far. Then they're saying this, the endpoint also supports ETAG and protobuf encoding. Okay, I don't know what these are, but I guess I'll discover them soon. Okay, but I need to read this statement again. They're saying this GitHub document can be used as a reference of the best set of the available resources if a Kubernetes cluster is not available to query. What is this document? Let's open it and see. I won't lose anything. Okay, so this is it. Some say JSON thing, okay? Like I seen this aggregated v2 JSON, okay? Simply a specification. I seen this thing, this version. Let me try to expand it or to zoom in so that you see. We have this API discovery.k8.io.v2, which was actually mentioned in the docs. Then we have the versions, blah, 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 okay? This is quite high level for now, but of course, I'm sure we'll understand it as we continue. So, number one, just to recap, sometimes I like going back to understand where I'm going. Okay, we're looking at the Kubernetes API. Okay, there are 2 ways to publish the specification of the API. Okay, to use an API, this API specification is required. Okay, we have the Discovery API and the full document Open API documentation. Right now we're looking at the Discovery API. Okay, Discovery API. Okay, simply publishes a list of a group versions and resources. Okay, having all this. Okay, and then under this Discovery API is also available under what they call aggregated discovery. Okay, and also under unaggregated discovery. We have just been reading about aggregated discovery. Okay, which offers the cluster through 2 endpoints, /API and /APIs. As simple as that. Then now when I go down here to unaggregated discovery, let's understand it. Okay, now they're saying without discovery aggregation, discovery is published in levels, with the root endpoints publishing discovery information for downstream documents. So many terms here. I hope they break it down later for us. Okay, but I won't give up. A list of all group versions supported by a cluster is published at the API and APIs endpoints. Okay, example. Okay, so they have here an example of their specification. Okay, I want to go back up here to see something. I want to see just the difference between aggregated and unaggregated. See, so they said aggregated discovery serves 2 endpoints, which we have seen. Okay, unaggregated discovery serves a separate endpoint for each group. Oh, now I get it. I get it. If, for example, like we had maybe 10 groups, okay, 10 group versions, okay, unaggregated would have 10 endpoints, okay? If we have 10 group versions, unaggregated discovery serves 10 endpoints. But if it is aggregated, there'll only be 2 endpoints for those 10 group versions. That is how I've now perceived it. If I'm wrong, don't hesitate to let me know. Okay? So they're saying a list of all group versions supported by a cluster is published at the API and /APIs endpoints. Example, Let us see. So this is the kind is API group list. The version is version 1. Then we have the groups, okay? So like we saw here, up here, okay? A group is made up of a name, a cluster, endpoint, alternative names, group, version, kind. So I guess down here is the same thing, okay? We have a name, okay, which is API registration.k8.io. Then we have a version, okay, which is a list, okay, versions I mean, and we have only one group version here, okay, group version, which is this, and the version value is this, v1. Then you have a preferred version, which is simply also an object, okay, and we have this, okay. I'm actually seeing that this is similar to this, okay. Actually, it's the same thing. Even this is the same. So I'm guessing they'll explain this ahead. The name, they're calling it apps, versions, so say list, okay. Group version, apps, v1, version, v1. Let me see. So I guess this is maybe this is the first group, okay. It's the first group. Then this should be the second group, okay. And so on and so forth, okay. So yeah, let's continue. Saying additional requests are needed. Let me highlight this first of all. They're saying additional requests are needed to obtain the discovery document for each group version. Okay. Just to read this again with a focused mind. Additional requests are needed to obtain the discovery document for each group version at APIs group version. For example, APIs slash rbsc dot authorization dot k8.io slash v1 alpha 1. Okay. And it's saying which advertises the list of resources under a particular group version. Okay. And they're saying these endpoints are used by kubectl to fetch the list of resources supported by a cluster. Okay. So if I move up, yeah, yes, understand. Remember, we have the API server. Okay. API server has specification, okay, of how to use the API, okay, and they're telling us their documents, okay, that have the specification for us to understand what the API is all about, okay. Any API should have API specification. There are two ways, okay, the Discovery API or the OpenAPI or interface definition, okay. For the Discovery API, there's the aggregated and unaggregated. For the aggregated, it gives you just two endpoints. For the unaggregated, for every group version, it is an endpoint. Okay. So like here for this group, I think for these groups, okay, you can see each of the groups that are listed here. I think there were two that we found. Okay. And they're saying, look at this, for each group, okay, for each group version, there's this endpoint. Okay. You obtain them at this endpoint, the API slash the group slash the version. Okay. So I'll say the API, for example, in this case, I'll say the API. Why should they give us an example here? Why should they hassle? This. Okay. Clear and simple. Now, remember, we just looked at the first way, okay, which is the Discovery API. Okay. And the Discovery API, like they told us, it doesn't have everything, but the Kubernetes Open API documentation provides everything. It's the full documentation. So let's now look at it. See the Open API interface definition. They're saying for details about the Open AI specification, see the Open API documentation. Sometimes I keep on saying Open AI or Open. I keep changing between AI and API. Crazy. So let's go on. They say Kubernetes serves both Open API version 2.0 and Open API version 3.0. They're saying Open API version 3 is the preferred method of accessing the Open API because it offers a more comprehensive lossless representation of Kubernetes resources. Okay. Simply it's better, it gives more. Okay. And then that's my takeaway from that statement. Then they're saying due to limitations of Open API version 2, certain fields are dropped from the published Open API, including but not limited to default, nullable, and one of. Since certain fields are dropped from the published Open API, including but not limited to default, nullable, and one of. I don't know what they mean by one of. Okay, I guess the things that should be explained as we move on in this study. Okay. All right. So they're saying Open API version 2. They're saying the Kubernetes API server serves an aggregated Open API version 2 spec via the Open API / version 2 endpoint. Okay. You can request the response format using request headers as follows. Okay. So this is the entire version documentation. Okay. The full docs. Where is it? This is what we're looking at. Okay. The full specification. And there are two versions. Okay. But version 3 is more comprehensive. So here they say they try to explain the headers. Okay. The request headers. Okay. This header called accepting according. The possible value is gzip, and is a note saying this not supplying this header is also acceptable. It's optional. Then you have accept. Okay. The possible values is either JSON or this protobuf stuff. Okay. And they're saying mainly for intra-cluster use within the cluster. Okay. So JSON is the default. Or you can put asterisk star, meaning everything. It says serves application JSON. But this is the default. Warning. Validation rules published as part of the Open API schemas may not be complete and usually aren't. Additional validation occurs within the API server. If you want precise and complete verification, a kubectl apply --dry -run equals server runs all the applicable validation and also activates admission time checks. The validation rules, just to read this again, the validation rules published as part of Open API schemas may not be complete and usually aren't. Okay, so the validation rules may not be complete. So we need additional validation, which is done for us within. Okay, it's done for us within the API server. This is good to know. Then I'll move ahead. Okay, and read what they're saying. They're saying now this is the version 3, okay? The one which is more comprehensive. They're saying the feature state of this is that it is stable, okay? And is enabled by default. Yes. Good. And of course, it's what I would use. I would want to use something that is more comprehensive. It's saying Kubernetes supports publishing a description of its APIs as Open API v3, okay? Version 3. Saying a Discovery endpoint Open API /v3, okay, is provided to see a list of all group or versions available. This endpoint only returns JSON. These group versions are provided in the following format. Okay, so this endpoint, okay, helps you to see a list of all group versions available, and it returns only JSON. So this is the version, okay? We have a key called path, then with another object here, okay? Could have some data, okay? Before it or more data, but I think this is strictly what it looks like, okay? The API /version is a key, okay? With another object. Then inside you have server relative URL, okay? With something like this, okay? We don't need to cram this, of course. Then another key, okay? Yeah, the goal is just to see the structure, okay? It's just how JSON is, okay? You don't need to cram all this. If it was need to cram all this would be insane, okay? Then I'll go ahead to read this. They're saying the relative URLs are pointing to immutable open API descriptions in order to improve client-side caching. Okay. The relative APIs are pointing to immutable open API descriptions in order to improve client-side caching. The proper HTTP caching headers are also set by the API server for that purpose. The proper HTTP caching headers are also set by the API server for that purpose. Okay, so we have expires to 1 year in the future and cache control to immutable. So they're saying when an absolute URL is used, the API server returns a redirect to the newest URL. Cool. Then they're saying the Kubernetes API server publishes an Open API v3 spec for Kubernetes group version at this. Okay, I won't cram this at this endpoint. Okay, refer to the table below for accepted request headers. So you have the accepting coding, which is gzip. Okay, saying not supplying this header is also acceptable. They have the accept header whose values can be either this, or this. Okay, this one is for mainly intra-cluster use. This is the default one, and this one serves JSON. Yeah, pretty interesting. So yeah, just going into details. They're saying a Golang implementation to fetch Open API version 3 is provided in the package, this K8 blah blah blah. Kubernetes 1.3 publishes Open API v2 and v3. There are no plans to support 3.1 in the future. I mean. Then we have protobuf serialization. They're saying Kubernetes implements an alternative protobuf based serialization format that is primarily intended for intra-cluster communication. For more information about this format, see the Kubernetes protobuf serialization design proposal and the interface definition language IDL files for schema located each schema located in the Go packages that define. I don't think I need to do that now. Okay. In any case, I will I think actually what I know is that when we start doing the practicals, okay, things will make more sense. But just doing an overview of what we're going to be dealing with gives a better foundation. That's why I want to build it first. So you're saying Kubernetes stores the serialized state of objects by writing them into etcd. Okay. Yeah, we know this. Okay, so etcd is a key value store. So they now bring about API groups and versioning. So they're saying to make it easier to eliminate fields or restructure resource representations, Kubernetes supports multiple API versions, each at a different API path, such as /API v1 or /APIs at this endpoint. Okay, so this is simply for representing, making it easier for us to eliminate fields, okay, or restructure resource representations. So Kubernetes supports multiple versions. That's good to know. So they're saying versioning is done at the API level rather than at the resource or field level to ensure that the API presents a clear, a consistent view of system resources behavior to enable controlling access to end of life or experimental APIs. To make it easier to evolve and to extend its API, Kubernetes implements API groups that can be enabled or disabled. They say API resources are distinguished by their API group, resource type, namespace, or namespaced resources, and name. They say the API server handles the conversion between API versions transparently. Okay, they say all different versions are actual representations of the same persisted data. Yeah, so in the end, it should be the same data. This makes sense. The API server may serve the same underlying data through multiple API versions. Yeah, just like in the real world, you may serve the same data using a REST or a GraphQL or a WebSocket, but you may be serving the same information. Okay. So you're saying, for example, suppose there are two API versions, okay, V1 and V1 beta for the same resource. Okay. If you originally, let's read this. You're saying if you originally created an object using the V1 beta version of its API, you can later read, update, or delete that object using either the V1 beta 1 or the V1 API version, okay, until the V1 beta 1 version is deprecated and removed. Yeah, so you're just trying to reinforce the point that the API server may serve the same underlying data through multiple versions, okay? So yeah, makes sense. So I think at that point you can continue accessing and modifying the object using the V1 API. So API changes. They're saying any system that is successful needs to grow and change as new use cases emerge or existing ones change. Therefore, Kubernetes has designed the Kubernetes API to continuously change and grow. The Kubernetes project aims to not break compatibility with existing clients and to maintain that compatibility for a length of time so that other projects have an opportunity to adapt. In general, new API resources and new resource fields can be added often and frequently. Elimination of resources or fields requires following the API deprecation policy. Kubernetes makes a strong commitment to maintain compatibility for the official Kubernetes API once they reach general availability (GA), typically at version 1. Additionally, Kubernetes maintains compatibility with data persisted via beta API versions of official Kubernetes APIs and ensures that data can be converted and accessed via GA API versions when the feature goes stable. If you adopt a beta API version, you will need to transition to a subsequent beta or stable API version once the API graduates. The best time to do this is while the beta API is in its deprecation period, since objects are simultaneously accessible via both API versions. Once the beta API completes its deprecation period and is no longer served, the replacement API version must be used. Okay, you're simply saying that later after you've made your adoption, okay, and everything is now stable, you can now replace the beta version. Okay, the thing a note. Although Kubernetes also aims to maintain compatibility for alpha API versions, in some circumstances, this is not possible. If you use any alpha API versions, check the release notes for Kubernetes when upgrading your cluster. In case the API did change in incompatible ways that require deleting all the existing alpha objects prior to upgrade. Yeah, this makes sense, I think, for all software in general. You need to do that. Then say refer to API versions reference for more details on the API version level definitions. Okay. I can't wait to actually use it. It's in the API extension. It's in the Kubernetes API can be extended in one of two ways. Custom resources let you declaratively define how the API server should be. I want to read this again. Custom resources let you declaratively define how the API server should provide your chosen API resource. Okay. Then you can also extend Kubernetes API by implementing an aggregation layer. Okay. This is when you need to extend the API. I think it's like for people who want to do let me say the third party providers. Okay. So yeah, this is some good information. Just know that you have a general sense of what the API server is all about. Okay. Before we now get into the practicals. So yeah, very soon we're going to be into the practicals. So let's finish setting up a good foundation this week. Thank you all for learning with me. Have a good day, and let's meet in the next stream.